Okay, this is homework 3.7, 3.10. And this was a cost function. We were asked to find the marginal cost by differentiating, of course, and then evaluate at 100. And we always get a rate of change, which has two measurement units. So that's the cost per item, rate at which the cost is increasing at the 100th as the 100th item is produced. The actual cost is delta C, C of 101 minus C of 100. I plugged this in the original function and I got this. And you see how close, in this case, very, very close. This was a particle moving on such a curve. And we were asked to find how fast is the distance between the origin and the particle changing at a particular instant. So here we have to write the Pythagorean theorem, x squared plus y squared equals w squared. And we are asked to find dw over dt when x is 1/3. So we differentiate implicitly. All these are functions of time. We divide by 2 and we solve with dw over dt, which is x dx plus y dy over w. Remember, 2 is gone. At this point, I realize that I don't have dy over dt, but that's okay because I have the function. So I will differentiate y with respect to time, but knowing that x is also a function of time. So when I do that, I get 2 cosine pi over x times pi over 2 times dx over dt. And once I plug everything in, and then eventually here, because I had 1/3, I had the square root of 10, I had 1, I didn't have the dy over dt, and the denominator is the square root of 1 over 9 plus 1. So then I plug everything in, and from the previous page where I had the square root of 3 pi over 2 times the square root of 10, or the square root of 30 pi over 2. Same thing. And put this in the calculator, remember, with parentheses around the top, and you get this, 9.16 centimeters per second. Here the kite is flying in this direction, giving to us dx over dt. And of course, we have to form a right triangle where the height is fixed over 100, and x is changing and y is changing. But I'm only interested in tangent theta because it's the opposite over the adjacent, 100 over x. I don't have any information about y per se, how fast it's changing. So then I solve, I change this into tangent theta equals 100 times x to negative 1, knowing that theta is a function of time, x is a function of time. When I differentiate this, I have secant squared theta times d theta over dt. I bring down negative 1, I subtract 1 from the power, and remember x is a function of time, so times the inner function prime, which is dx over dt. So I have to solve for d theta over dt, all this over secant squared. When y equals 200, then sine of theta is 100 over 200, which is 1/2, which means theta must be pi over 6. And x will be the square root of 200 squared minus 100 squared. So what do I have here? I copy negative 100. I copy dx over dt, which is 8. I copy x squared, which is 200 squared minus 100 squared. And the denominator, when theta is pi over 6, cosine pi over 6 is square root of 3 over 2. So the square root of 3 over 2 squared will be 3 over 4, and when I flip, I get 4 over 3. So that's how I get secant squared to be 4 over 3. When I calculate all this, I get negative 0.02 radians per second. Here we're asked to find the linearization. So it's f of 0 plus f prime of 0 times x minus 0. The derivative is 3 e to 3x. The derivative evaluated at 0 is 3. The function evaluated at 0 is 1. So that's how I get 1 plus x times 3, or 3x plus 1. Here we're asked to find the differential, not the derivative of y. So dy will be 2 theta times sine plus theta squared times sine prime, which is cosine 2 theta times the inner function prime, d theta. So I just rearranged a little bit by putting 2 in front. Same thing here, we're asked to find dy, which is y prime times dx. The top prime is 1 times the denominator minus the top times the denominator prime, but I have to distribute -1. So these two go away, -2 over x minus 1 squared dx. And I'm asked to plug in, for x, it was 2, and for dx, it was 0.05, so I get this. Now we're asked to either use the approximation or linear approximation or differentials. No matter which one you use, you get the same thing, and it's basically the same idea. So cosine 29 will be f of x, which is x is 30. Dx is -1 degree, but it has to be changed into radians. F of x is cosine, f prime is negative sine x. So negative sine x of 30 degrees is -1/2. Cosine x here is the square root of 3 over 2. And dx is -5/180. And that will give us 180, the square root of 3 plus pi, or 360, when the least common denominator is 360, and I need to multiply this by 180. And exactly the same steps, exactly the same numbers, everything the same with the linear approximation. Here we were asked to find how the maximum error in the hypotenuse when the maximum error in the angle is plus or minus 1 degree. And we are given the opposite, we are given the angle, but there is an error in the angle, so the error in the angle would trigger an error in the hypotenuse. So sine theta is 20 over w. I cross multiplied and solve for w, so I get, or swap these two, the same thing. 20 over sine theta, or 20 times sine, not inverse, but sine theta raised to -1. It's easier to differentiate. Bring down -1, subtract 1 from the power, and differentiate the inner function times d theta. So I bring this to the denominator. I get -20 cosine, and this is in the denominator, and d theta. And now I plug in the numbers, and I get this. So 20, the square root of 3 over 2, 1 over 4, because this is 1/2 squared. And d theta is plus or minus 1 degree, but I have to change it into radians. So I got plus or minus 1.2 blah, blah, blah centimeters, or plus or minus approximately 1.21. And also we are asked to find the relative error, which is the error. I copied it from here. I copied this here at the top, exactly what I have. And then I simplified the 20 with the 20 and the sine with the sine. So what is left is the negative. It's cosine at the top, one of the sines in the denominator, and d theta. I plugged in the numbers, the square root of 3 over 2 over 1/2, the minus in front, and d theta is plus or minus 1 pi over 180. Perform the calculations. There is no measurement unit here because this is centimeters over centimeters. No measurement unit. It's plus or minus 0.03 or 3%. Thank you.